Thermodynamics. Definition of bond dissociation entropy. Entropy change when all the bonds are the same type in 1 mole of gaseous molecules are broken. Definition of entropy change of atomization of a compound. Entropy change of 1 mole of a compound in the standard state is converted into gaseous atoms. Entropy change of atomization of an element. Entropy change of 1 mole of gaseous atoms is formed from an element in standard state. First electron affinity. The entropy change of 1 mole of gaseous 1 minus ions is formed from 1 mole of gaseous atoms. Second electron affinity. Entropy change of 1 mole of gaseous 2 minus ions is formed from 1 mole of gaseous 1 minus ions. Entropy change of solution. Entropy change of 1 mole of solute is dissolved in enough solvent so that no further entropy change occurs on further dilution. Entropy change of hydration. Entropy change of 1 mole of aqueous ions is formed from 1 mole of gaseous ions. Lattice entropy. A measure of ionic bond strength. Lattice entropy of formation. Entropy change of 1 mole of a solid ionic compound is formed from its gaseous ions under standard conditions. Lattice entropy of dissociation. Entropy change of 1 mole of solid ionic compound is completely dissociated into its gaseous ions under standard conditions. It said two assumptions of a purely ionic model of a lattice. All ions are spherical, have the charge evenly distributed across around them. Describe the covalent bonding. So I should have worded this differently, but the idea that positive and negative ions aren't exactly spherical. Positive ions polarize the neighboring negative ions to different extents. More polarization, therefore more covalent the bonding. And you can see here, unpolarized ions, purely ionic bonding, whereas with polarized ion, partial covalent bonding, they're not exactly spherical. So the two things that happen when a solid ionic lattice dissolves in water. Bonds between the ions break to give free ions. This is endothermic, positive delta H. Bond between the ions and water are made. This is negative delta H, exothermic. Entropy change of solution is the overall effect on entropy of these two things. Bonds between the ions and bonds between the ions breaking to give free ions, and bonds between the ions and water made. So bonds between the ions to break to give free ions, or bonds between the ions and water made. Entropy change solution to overall effect on entropy of these two things. Describe water and a dipole. Well, water molecules bond to ions as oxygen is more electronegative than hydrogen. Therefore, it draws electrons to itself, creating a dipole. The dipole means positively charged H atoms form bonds with negative ions, and the negatively charged oxygen atom forms bonds with positively charged ions, or H plus ions. Say a key fact about substances. Substances generally only dissolve if the energy released is equal to or is the same as or greater than the energy taken in. Therefore, generally soluble substances have exothermic entropies of solution. Definition of entropy: S, a measure of the number of ways particles can be arranged and the number of ways energy can be shared out between the particles. Substances tend to disorder, more stable when more disorder, and particles move to increase their entropy. Definition of standard entropy of a substance: S, like this, with circle and line through it. It's the entropy of 1 mole of that substance under standard conditions. And the standard conditions are 298 Kelvin and 100 kilopascals. Entropy of 1 mole of that substance under standard conditions. If delta H is positive and delta S is positive, reaction won't be feasible at some temperatures but will be at high enough temperatures. If delta H is negative and delta S is negative, reaction will be feasible at lower temperatures but won't be feasible at higher temperatures.